Hey, what's going on, guys? Let's see how we can do this problem right here. The question is asking 5 capacitors are connected across potential difference VAB as shown in the picture. Because of the dielectric used, each capacitor will break down if the potential across it exceeds 30 voltage. The largest that VAB can be without damaging any of the capacitors close to which values, right? So that's the question is asking. So let's see how we can figure it out. So first of all, we have to find the charge for this one because we know that V is equal to Q is equal to CV, same thing. So here we are trying to find the VAB, right? So we are trying to find the VAB, and using this information, we have to find the charge. So the potential differences are high in the lowest capacitance. So here we have to choose the lowest capacitance to find the charge. So if you look at this one, the 5 microfarad is the lowest capacitance, right? So we have to find the charge in this one. If we find one charge, we know that this is a series, so the charge is going to be same across the circuit. So let's find the charge right here using Q is equal to CV. So Q is equal to CV. We know that this is 5 microfarad. So this is going to be 5 microfarad times the voltage is 30 voltage. So 30 voltage, and that's going to give us 150 microcoulomb, right? So this is what we have. Now we have the charge. Now we have to find the total capacitance. To find the total capacitance across a series, for a series we have to add like this. Like 1 over CT is going to be equal to 1 over 50, 1 over, so this is like for a series of a capacitance, it goes like this. For a series of a resistance, we just simply add them directly, right? So that's the difference for a capacitance and a resistor. So let's add them like this. So this is going to be 1 over 15, 1 over 45, plus 1 over 5, plus 1 over 25, 1 over 10, right? Now we have to find a common denominator to add them. So when we find the common denominator, that should be multiplication of this 45 and 25. So if you think about this, 450 seems like it will work. So let's take 450 as a common denominator. If I take 450 common denominator, this is going to be times 30, right? So this is going to be 30 plus 10 plus 5 times 80 is 400, 5 times 10 is, so it's going to be 90. And then we have 25 times 4 is 100, 20, therefore 4 times 4 16, so this is going to be 18, right? 18 times 25 is going to be 450. So let's make sure. 25 times 4 is 100, 4 times 4 is 16 plus 2, right? So that's 18, and 10 is going to be just 45. So now let's add them together. So here we are going to have 40 plus 90, that's going to be 130, 148, 148 plus 5 is going to be 153, 193. So 193 divided by 450. So this is going to be the total capacitance. So this is in microfarads, right? So all of them are in microfarads. Now we have to find the VAB. So to find the VAB, we are going to use Q is equal to CV equation. So V is equal to Q over C. So we know the charge already. We found out right here 150 microcoulomb. So 150 microcoulomb divided by 193 divided by 4. Oh, you know what? We have to flip this around. This is 1 over CT, so here CT is going to be 450 divided by 193, right? So that's going to be microfarad, and that's good thing. That's a good thing because it will cancel with 450. So let's take that value. So this is going to be 450 over 193 microfarad. So here 150 and 450 cancels. So this is going to be just 3, right? And 193 flips around and go to top, so this is going to be 193 divided by 3. So let's calculate this one. 193 divided by 3. 3 times 6 is 18. 30. So this is going to be 4. 12. 1 0. So 64.3. Then 9 1. So it's going to go like 64.3333, something like that. So that's going to be the final answer. So here the answer is 64.333 volt. So therefore the answer for this one is going to be 64 volts. And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.